Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to graph a rational function that has a slant asymptote. Notice that the degree in the numerator, 2, is greater than the degree in the denominator, 1. We still will follow the pattern we've been using so far, starting with the vertical asymptote. And that's where x plus 3 equals 0, or x is negative 3. So let's zoom in on that first. All right. Next, we can, before I go looking for the slant asymptote, I'm going to get some points onto this graph that I know. And I can start with the zeros, which come from the numerator. This is x minus 4 times x plus 2. So the zeros are at x equals 4 and x equals negative 2. X equals 4, x equals negative 2. I can find the y-intercept, which is f of 0. F of 0, when we put in 0 to the function, 0 squared minus 2 times 0 minus 8 over 0 plus 3. The zeros fall out and we get negative 8 over 3. That's about 2/3 of the way between negative 2 and negative 3. So about here. It's an interesting function so far. The next thing that we should do is find the slant asymptote. And so what we want to do is we want to divide x plus 3 into x squared minus 2x minus 8, but we can do that using synthetic division. So negative 3 goes in the box. The coefficients are 1, negative 2, and negative 8. Bring down the 1. Multiply. Negative 3 times 1 is negative 3. Total the column, negative 5. Negative 3 times negative 5 is 15. Total the column, we get a remainder of 7. So the quotient here is x minus 5 plus 7 over x plus 3. And that makes the slant asymptote y equals x minus 5. So that goes through the y-axis at negative 5 with a slope of 1. So negative 5, its slope is 1. Use the opposite pattern going to the left. So again, that's the slant asymptote. Y equals x minus 5. All right, so how does this graph behave from here? Well, we pretty much have the top quadrant of this graph set. It's got to approach the slant asymptote. It's got to approach the vertical asymptote. And so it looks like it's going to have to go down and bend like that. So let's zoom in and give a rough sketch of that. And so that's going to continue on to the right. And so I don't have to worry about this area, right? Worry about graphing it below there. But I do need to figure out what happens to the left of negative 3. And so I really have two options for this graph. It's either going to look something like this, or it's going to look something like this. And what I really need to do is plug in negative 4 for x and see what I have to work with. So when x is negative 4, let's take a look at the function and see what we get. Negative 4 squared minus 2 times negative 4 minus 8 over negative 4 plus 3. on the top, that's going to be 16 plus 8 minus 8 over negative 4 plus 3. And this works out to be 16 over negative 1, or negative 16. So at negative 4, this graph's going to be way down here at negative 16. So if I continue the asymptotes, that tells me it's going to look something like this. All right, there you go. There's one with a slant asymptote.